Now, solution of triangles. Solution of triangles. The sine rule. Capital letter represents angles, while small letter stands for side. In the diagram, two triangles ABC and ABD are inscribed in the circle ABCD of center O. BC equals to A, while AB equals to C equals to D. BD is R plus R, OB is R, OD is R. Now, BD is R plus R, which is 2R, and that is given as side A in triangle ABD. BCA equals to BDA. Angle in the same segment are equal. BAD, in the diagram BAD, angle A is 90 degrees. Angle in the semicircle is 90 degrees. Is a right angle triangle. BAD is 90 degrees. Angle in the semicircle is right angle. Sine D. Sine D is given as D over 2R. Opposite over hypotenuse. The opposite is D. If you take the triangle ABD, the opposite for angle D is D, while the hypotenuse is 2R. Opposite over hypotenuse. Sine D gives D over 2R. Similarly, since angle C equals to angle D, sine C is C over 2R. Therefore, 2R is C over sine C. Now, sine B. Sine B is given as B over 2R. So 2R is written as B over sine B. Let's call that equation 2. Similarly, sine A will be given as A over 2R, which is 2R. So in that, if we combine 1, 2, and 3, equation 1, 2, and 3, A over sine A equals to B over sine B equals to C over sine C equals to 2R. Or we can write it as A over sine A equals to B over sine B equals to C over sine C. This is called the sine rule or formula, where A, B, and C are all acute angles. Now let's look at the cosine rule. The cosine rule. Using Pythagoras theorem in that diagram ABC, C square is C square equals to X square plus H square, equation 1. Now B square is same thing as A minus X square plus H square in that diagram. So B square is A minus X square plus H square. B square is given as A square plus C square minus 2AC. Let's call that equation 3. In triangle ABD, cos B is given as X over C, while X is C cos B. X equals to C cos B. Hence equation 3 becomes B square equals to A square plus C square minus 2AC cos B. Let's go over it again. Now, in the diagram, in triangle ABD, using Pythagoras theorem, small letter B is given as B square is A minus X square plus H square. Similarly, C square is X square plus H square. That's equation 1 and equation 2 there above. Since equation 1 and 2, expanding equation 2, we can have A square minus 2AX plus X square plus H square. But from equation 1, we know that C square is X square plus H square. So substituting that in equation 2, I have B square equals to A square plus C square minus 2AX. Call that equation 3. In diagram ABD, cos B is X over C. So X is C cos B. Hence equation 3 becomes b square equals to a square plus c square minus 2ac cos b. Similarly, a square is given as b square plus c square minus 2bc cos a, and c square is given as a square plus b square minus 2ab cos c. We could write that cosine formula as cos a, which is b square plus c square minus a square over 2bc, or cos b is given as a square plus c square minus b square over 2ac. These formulas are called the cosine rule or formula. The sine and cosine rule are useful tools in solving triangles. Let's look at area of triangles. The area of triangles. For any right angle triangle, the formula for finding the area is given as area is half base times height. However, if the triangle is not a right angle, then the area becomes half AC sine B, or half AB sine C, or area is same thing as half AC sine A. If you look at the two diagrams below, if ABC, angle A is at right angle, we can use half base times height. But in figure 2, we cannot use half base times height. So because those angles are arched, there is no right angle diagram there in figure 2. Hero's or Aaron's formula. When the three sides of a triangle are given, the area of the triangle is found by using the Hero's formula. Area equals to root x into x minus a into x minus b into x minus c, where s is given as half into a plus b plus c. A, B, C there are the sides of the triangle. Now let's look at half angle formula for any triangle. The half angle formula for any triangle is given as sine A over 2, which is root x into minus bx minus c over bc, and cos b over 2 is given as root x minus c x into x minus b over ac. Similarly, for tan A over 2, tan A over 2 is given as root x minus b into x minus c over x into x minus a, and tan B over 2 is given as square root of x minus a x minus b over x into x minus b. The tangent rule is given as tan b minus c over 2, which is the same thing as b minus c over b plus c cot a over 2. Or we could also find there is another formula for tangent rule. Tan a minus b over 2 into a is the same thing as a minus b over a plus b cot c over 2. Take note, capital letter stands for angle and small letter stands for size. So we could extend that. We can also find tan a minus c or tan b minus a. We'll just change the formula on the right hand side. For 3, tan c plus a over 2 is c plus a over c minus a tan c minus a over 2. While tan a plus b over 2 is given as a plus b over a minus b tan a minus b over 2. Similarly, we can also find tan a plus c or tan b plus c. Tan b plus c over 2 will be given as tan b plus c over 2 will be given as b plus c over b minus c tan b plus capital B plus c over 2. Now let's look at example on that. When solve the triangle in which A is 14 cm, C is 17 cm, and angle B is 25 degrees using the tangent rule. Solution. Using the tangent rule, I have, since A, small a, and C and capital B are given, we make use of the tangent formula of the form tan C minus A over 2 equals to C minus A over C plus A cot B over 2. And small c is 17, small a is 14. So substituting, capital B is 25 degrees. Substituting to the formula, we have 17 minus 14 into 17 plus 14 cot 25 over 2. And that reduces to 0.4365. So on the left hand side, I have tan C over C minus A over 2 equals to 0.4365. So C minus A, taking tan to the other side, I have C minus A over 2 is given by arc tan 0.4365 0.4365. So tan c plus a, similarly, also from that formula, tan c plus a over 2 is given as c plus a over c minus a tan c minus a over 2. Substituting, 17, c is 17, a is 14. 17 plus 14 over 17 minus 14. Already we've calculated c minus a tan c minus a over 2 to give us 0.4365. Now, tan c plus a over 2 is given by 4.5015. So c plus a over 2 will give us arctan 4.5015. So c plus a, if you take 2 to the other side, c plus a is 155 degree. Got that equation 2. Solving 1 and 2 simultaneously, we have angle A to be 53.92 degree and angle C to be 101.08